image data is used. So there are there is a topic, there is a main field, that is a computer vision, where we use images a lot. Like whenever we have to analyze some data, we have to virtualize it. Okay, so let's say for an example, if a human have to analyze something, it human analyzes it with its visualization. Okay, so whatever human see, whatever human hear, based on that human analyze that data. Okay, so computer vision is nothing but a virtually analyze this data using images. So there is a definition: computer vision is a field of study within artificial intelligence that focuses on enabling computers to intercept and extract information from images and videos in a manner similar to human vision. जैसे हम देखते हैं कि इमेजेस में या फिर वीडियोस में जो भी डेटा होता है वो हम एनालाइज करके उसे क्लासिफिकेशन वगैरह करते हैं, तो वो किस तरीके से होता है, वो इमेज का फीचर एक्सट्रैक्शन किस तरीके से होने वाला है, वो चीजें आज हम देखने वाले हैं. सो नेक्स्ट, where is computer vision is used. So, in a healthcare sector, that is our topic, detection of anomalies in MRI, CAT, and X-rays. Like anomalies, like suppose we are going to see a cancer disease prediction. So there are multiple images we have. Okay. So the labels are the person having a cancer, the person is not having a cancer. So anomalies are the person that is having a cancer. There are some X-ray is that is different from the normal people. Okay, that is called as the anomalies. Then MRI and CAT scans. These images is also have a anomalies, like that is different than normal persons. Then diagnostic assistance, calculation of blood cells, retina scans, and early detection of structural changes. So we are going to see this project in the last, identification and analysis of new recurring skin anomalies. So these are the applications of computer vision in healthcare section. Next, how image detection, how image processing works in CNN. So there is our model CNN, convolutional neural network. Okay, so how it is work? So let's we have one model, that is a ANN. Okay, so ANN is work well on a textual data or CSV data. But whenever we are talking about the image based data or video based data, the ANN does not work properly. That is why we have one model, convolutional neural network. So here is the architecture of convolutional neural network model. So there, how it analyze the data. Here we have an inputs, like we have images. So we gave convolutional model that images as an input. Then this model extract that data from an images. So for showing this, let's have an experiment. Okay, I'm going to show you one image, and based on that, you have to predict which shape is that. Okay, I'm going to show you only for 2 seconds. Okay, so this is the image, and next. So, which image is similar to the previous image? That second image. So, how we analyze this? That these images is similar to previous image. Okay. So based on we analyzes its shape, its edges, how many edges are there, okay, how it is looking. So similar to that, the computer also analyzes by its edges and by its shape. Okay, so in a human brain, when we see anything, we analyzes its structure, how it is looking, how the edges are, how many sides the shapes having. Okay, based on that, in a the time of 2 seconds, you can able to identify the image. Okay, so next, so there is a famous experiment, it is on a cat. So scientists give anesthesia to the cat, and based on that, they they show some pictures to the cat. Okay, so here there is a cathode ray placed in inside its brain, and then the single cell analysis. So here is the first image. Okay, so the cell does not react anything. Here is the second image. The cell again does not react anything. Okay, so a single cell will analyze only for a particular pattern. So there is a third image. The cell is react. There is a fourth cell also react. There is a fifth image where cell reacts more. Okay, यहाँ पे क्या हुआ है कि सेल ने सबसे ज्यादा रिएक्ट किया है, देन अगेन सेल ने ज्यादा रिएक्ट नहीं किया है, देन अगेन लास्ट टू इमेजेस देयर इज अ नो रिस्पॉन्स फ्रॉम द सेल. So based on these experiments, scientists found that. Okay, based on this experiment, scientists found that cell 1 is able to identify only a single pattern, that is this. Okay, then they simultaneously perform this experiment on different sides using cathode rays. So next time whenever the cell 2 is analyzed, the pattern is this. Okay, so the second cell is react more for this pattern, then third cell is reacting more for this pattern, then fourth cell is reacting for this. So this single cell is giving stimulus responses to the data scientist, and cell 1 for this pattern, cell 2 for this pattern, and let's say cell 3 for uh, this pattern. Okay, so now from here, they found that in a brain there are two types of cell. First one is simple cell, and second one complex cell. So simple cell analyzes only a single pattern or a single edge. Okay, so single edge and complex. So combination of three or two or more simple cells then analyzed by complex cell. It is called complex. So based on this pattern, so there are three patterns we have: vertical, horizontal, again vertical. So based on this, simple cell, complex cell is analyzing that the pattern is octagon. Okay, so previously we have a octagon. So simple cell, single edge is analyzed by simple cell, and then it is merged for a complex cell. Complex cell is analyzing. So how our complex convolutional neural network work. So here we have a simple cell and complex cell. Then, so in a stage 1, we are going to analyze some simple cells based on a single cell. So here is a diagonal pattern, here is a horizontal pattern, here is a vertical, and again here is dominant diagonal pattern. So based on that, by combining two or more simple cell, we are getting this pattern. Again, we are getting this pattern by combining two or more edges. Again, here we are getting two pattern. Then by combining stage 2, we are getting this pattern. Okay, again we are getting, and finally in the last stage we are getting our proper output that we gave at the first, that we gave as an input. So based on that, our brain, or our convolutional model is analyzing this data. Okay, so how we extract the feature from images? So here we have an image. So again, convolutional images detect these images. First they detect edges, and then they convert these edges into a complex pattern. Okay, then how convolutional works on a grayscale images and RGB images. Okay. So suppose we have an data, we have an convolutional network, neural network, and we have matrix. So our image data, it is in a format of a matrix. So here you can see that there is a information, there is a more information in the left side. Then we have to create this image in a feature image, feature map. So for converting this image in a feature map, we have to give a filter and multiply it with the that feature map. So we are giving here a 3 by 3 matrix as a filter, okay, and multiplying this filter with this 6 into 6 6 by 6 image. So we are getting this filter map, okay. That is a convolutional filter map uh, is gated gate here. So this layer, convolutional layer, convert our images in a filter map. Okay. So we have ANN, we have a neural simple neural network model. So there we do not have a convolutional layer. What our convolutional layer is doing, it is converting our images in a simple small images, and then it is giving to the model for analyzation for finding its pattern. So so here you can see that, so how this pattern is get like convolutional. So suppose we have this pattern. Okay, and we are giving a 3 by 3 matrix. So what what is happening here? So first 3 by 3 matrix is ma'am second uh, marker color है इसमें black. Okay, okay, fine. So so first 3 by 3 is getting calculated with this area. Then we slightly move it towards right. Then it is calculating with this area, and we are getting a result of 4 by 4 matrix. So by calculating this 3 by 3 matrix in the first here, we are getting the value of this model. So then next we are calculating this with this. So we are getting the value of this point. Okay. So practically we are going to see. So here, if you can see, hmm, okay. So So it is a pooling layer, but you can see here we are forming these images by calculating a filter map on our input data. So we are getting the same result here. So what is convolutional model doing? So it is extracting the features from our data. 1 second, let it load. connection. Okay. Hmm. So here, if we calculate it one by one, so you can understand. So here you can see that there is a combination, there is a pattern is forming. Okay, if we see step wise, okay, if I calculate with this in a by 3 by 3 matrix, you can see that the number is forming. So if I play this, okay, so here you can see that the pattern is formed. So there are two types of pattern here. There is red edge and there is a blue color edge. So suppose there the red color edge is that is a vertical and sorry, that is the left edge, and the blue color edge red is a left edge and blue color edge is a right edge, right side edge. Okay, so based on that you can find the pattern. Okay, so in ANN if we give data, it is take as a pixel value p1, p2, p3. Suppose we have a 255 pixels, there is a column or there is a 255 columns, but uh, you can see that zero. Suppose we are writing zero, like that we are writing. So ANN cannot able to find, because here the pixel values are different for these two images, but the pattern is same. So we have to analyze the difference between these. Okay, so from one edge to second edge, we have to find the difference. So for this, we have to use a CNN model. Okay, so for so again, as I say before, the it calculate the edges. So there are two edges, left edge and right edge. Left edge is representing by red color, and right edge is representing by the blue color. So based on that, it is forming a first simple cell architecture. Then by combining simple cell, the it is forming a complex. Then one it is forming pattern like this. Okay, so first it is a grayscale image. Then second, if we have a RGB image, suppose we have a 6 by 6, and we are converting it by convoluting with the 3 by 3 matrix. Suppose we have 28 by 28 image, how we can and we are calculating it with the 3 by 3 matrix. What matrix we will get after this? So we have one formula, that is a m minus n plus 1, that is m is this value, m into m, and n is this value. So 28 minus 3 plus 1, so what we will get 26. So 26 by 20 matrix we will get after filtering by with the different kind of data here. So with the RGB, there are three channels here. Okay, first one is red color, RGB full form red, green and blue. Okay, so first we have a red color channel, then we have a green color, and by again convoluting it with the 3 by 3 matrix, we are we will get a 4 by 4 matrix. Then how will it get calculated? So first it will calculate this matrix, then with the green matrix, then blue matrix, and by combining them we will get this value. So again, how we get this value? So suppose we have 1 into 1 plus 2 into 1 plus minus 1 into 1, then continuously by adding this value we will get this value. Okay, within a different channel. Then then in this image, what we what problem we will face? So suppose we have an image and we are convoluting it with the matrix 2, 5, 6, 7, 8. So while convoluting with this model, we will get, suppose we are getting this matrix, then this, then this. We will get these values, but when we are while traversing towards next, we have this value. So this feature is representing only single time, but in the matrix it is suppose it is an important feature, and we are going to lose it while we are convoluting with this module. So there is a important concept, that is a padding. You have to add padding to your data. What what is padding? So adding one row, one one column at the end and at the beginning of your data. So by padding, you will you will not lose the end features of your data. That is this. So before padding, what we are going we are seeing. So this data is this data. So this end feature we are going to lose, because this is representing only single time, but by adding the padding to our data we are not going to lose, as it occur many time in our data. So by adding three padding, so what we have 30 rows. Okay, we have 30 rows and again 3 by 3. So by calculating in that formula 30 minus 3 plus 1, so we are getting actually actual matrix 28 28. That is our actual matrix. So padding is useful when you have a very low dimension and very, and the end features are really useful. Then next next is stride. So stride is useful when, like, we are calculating this feature, this filter with single, and we are moving towards right by 1. So stride means if you increase the value of stride by 2, it is moving right by 2 columns. So first here we are calculating this and it is moving towards right by 2 columns. So it is it will ignore this column and it will fetch this column. So we will get the value of this column by incrementing stride value as 2. Okay, so when to use strides and when to use padding? So if you have really important data and you do not want to lose this data, you have to use padding. Okay, I'm going to show you where, when to use stride or when to use padding. So padding is really useful that we. Hmm. Hmm. Right. Hmm. Yeah. Yeah, it may possible. So here are the advantages and disadvantages of stride. When you have a high level features, when you have a high level dimensions, you have to use a stride. Okay, when you have a like 255 by 255 dimension image, you can use stride there. Okay, so there you have a less chances of losing data. But if you have a less dimension image, you cannot use a stride. So now there are models you can so when we implement the stride as the one, okay, the computing power is slow for our algorithm because it is actually shifting right by only 1 point. Okay, so by keeping stride as a one, it will not lose any feature, but it will slow down your computing power. By increasing stride, it will it will faster your computing power, but you may lose your features. Okay, so there are currently there are algorithms they use stride as only one. Okay, and their computing power is also good. Okay, देन इम्प्रूव कंप्यूटिंग पावर स्ट्राइड अगर आप स्ट्राइड यूज करते हो 2 और 3 ये कंप्यूटिंग पावर यूज इम्प्रूव करता है देन हाई लेवल फीचर्स अगर आपके डेटा में कुछ हाई लेवल फीचर्स है तो वहां पे भी आप स्ट्राइड्स को यूज कर सकते हो आगे हम पूलिंग में देखेंगे कि स्ट्राइड्स किस तरीके से यूज किए जाते हैं देन इंपॉर्टेंस ऑफ पैडिंग सेव्स फ्रॉम लूजिंग इंपॉर्टेंट फीचर जैसे कि मैंने बोला कि यहाँ पे क्या हो गया था ये जो साइड वाले जो फीचर्स है एंड वाले जो फीचर्स है हम वो यहाँ पे लूज कर गए थे देन आफ्टर एडिंग पैडिंग we are not going to lose any feature that our original size is 28 but after adding padding we are getting a size of 30 by 30 and by calculating we are getting a 20 by 28 by 28 feature map after filtering then next is pooling. Okay, so what is what we are doing by convolutional neural network? So we are extracting the features from our data. So how pooling, how convolutional works? So we saw that how convolutional works. So how pooling is work? How pooling works. So here we have an image that is a 4 by 4 matrix and we are going to convert it in a 2 by 2 matrix. So how pooling works? So suppose we are filtering it with the value of 2 by 2 by 2 and here our stride value is 2 2. So whenever I am going to see, so filter value is 2 by 2. So suppose here my the my max pool operator is working. So from max pool, so from these four values, which is the my maximum value that is 9. So we take 9. Then our stride value is 2. 2 by 2. By row we are going two positions. By column we are going two positions. So here in a second second filter my maximum value is 7. So here the value is 7. Okay. Then next we are going downwards here our again stride value is 2 then from here our maximum value is 8 and our maximum value is 6 okay so how pooling works so again let's see so if you go to this deeplizard.com you can see your actual representation. Here you can see that there is a zero. You can change the data set from here. There is a two data set amnist and fashion amnist. Then filter. You can add filter. Currently I'm using 2 by 2 filter. That's it. Okay. So let's say we are going to see 8. You can say here 8. Okay. So after converting this, okay, stepwise. So I'm going to play this. Okay, so so by pooling, we are reducing its dimension. Why we are reducing its dimension? Suppose, let's say we have an image that is a 255 by 255 pixels. So whenever I convoluting this with the filter, it will generate a size of 19 MB. Okay, it is only a single image. Okay, and suppose we have an data for 100 images. So how much storage it will take? Near about it will take a 1.5 GB, right? Okay. So if we do not use pooling, it will generate a 1.5 GB of storage. It will store its data in this storage. So it again, the computing power will be slow, and by using more storage, it will be complicated for algorithm. It will take more time. Okay, so by adding pooling in that area, we are going to convert our high dimension image, that is a 255 by 255 by 255, into lower damage by adding a pooling layer, that is this. So you can see that our our image is converted, but the dimensions, if you can see, the image is same for both of this. Okay, it is website deeplizard.com. Yeah. Hmm. I will provide link to your group. Okay, so yeah, yeah. uh Then you can see here deeplizard.com. There are tutorials. There is a convolutional demo. There is a max pooling demo. Okay. From here you can understand the values and you can change the dataset also. There are two datasets, MNIST and Fashion MNIST. Then let's move forward. So we saw that how pooling works. So what is the main thing? So suppose we have data. Suppose we have image 1, 1. What is the difference in these images? The one is position in the right side, this is left side, and this is center. So if we do not use pooling or any other method, so our model, suppose we are giving only these images. Okay, so our model what our model identifies, so if there is a edges that is present in this region only, it will show the images that is the one is occurring at the right side, only classify them into a one. If suppose there is a one at the left hand side, then it will not classify it in class 1. Okay, so why it is working like this? So it is position. So when when the model works, so it is actually identifying its position. So there is a position at the left side. There is no one. Okay, so it will identify one if one is present only at the left side. So by applying pooling, what we are getting, so here you can see that there is a f present at the left side, here is a 8 present at the right side, and here is a 8 present slightly towards right side. Okay, so by applying pooling, it is converting the same image. Okay, by applying pooling, it is creating same image. Okay, so after pooling, it is easy to identify for our model that that the images are same and they position in the same blocks. Okay, So that is why pooling is important for our image data set, that it will convert the same type of images. Okay. So next technique, data augmentation. So when to use data augmentation? So if suppose we have a very less images, that is two or three images, then we can use a data augmentation technique. What data augmentation do? It will convert an image into a multiple images. Like, suppose if we do not apply a data augmentation, and we gave it only single image. Okay, so our model will only work that if the cat, there are 4 to 5 pictures we are giving as a for testing, and there are images like, if we have images of cat like this. Okay, so suppose cat is seeing towards left and sorry, right, and here we gave an input that is the cat seeing towards left hand side. So our model will only identify a cat if it is looking towards left. Okay, so here the chances, so we have to generate more images. So that is why the data augmentation technique help us to generate more images. So here we are converting this image into a horizontal, then vertical, then we rotate it 45 degrees to the right, then 45 degrees to the left. We generate image as a blur, brighter, noise added, darker, grayscale, and crop. Okay, so now our model has a more data, and it will identify these cat images better. So if we give only single images, there are chances of overfitting, that I say कि अगर कैट लेफ्ट हैंड साइड में देख रही है तो वो उसी कैट को एनालाइज करेगा जो लेफ्ट साइड में देख रही होगी, अगर राइट में देख रही होगी तो वो नहीं, उसे कैट क्लासिफाई नहीं करेगा. ओके, so so now let's see let's see an example. Okay, I'm going to show you the eye eye illness detection. So here the data is, our batch size is 12, image size is 256, then channel is 3, epochs are 50. Then we are going to use this eye disease. So here is my full zip file. I will give this zip file to you after this session. So here what is added, so there I add a image size that is a 256 by 256. Then there is a eye disease folder. In that folder we can see there are images, that is a first disease, that is a endophthalmitis, and then a ideolum, then keratitis. So we are going to classify in these three classes. So if you see, there are three types of classes. Then by images, you can converting these classes in a 0, 1, 2 format. That 0 means endophthalmitis, and then 1 means hordeolum tight, then 2 means keratitis. Then we are going to see some of this image. So keratitis, there are some graphs, there are some reports, and there are some eye images we have. So it is classifying in keratitis. So you can see that hydeolum style, this condition. If I run this again, okay, you can see these images. I will give the dataset link also. So first we are going to split this data in a training testing state. Then here is my function to convert this data into a training and testing state. We are shuffling this data that that our model will train for really better. So here training, validation, and testing get dataset. We call this function. Okay. Then this function return us three value in the this three parameters. So the length of a training data set, that is again, okay. So let's run this one. So here, then we are if suppose we have a image that have a lower size, we are converting this image that is in a 255 by 255 pixel using this function. Okay, then we are going to see augmentation. We are using this augmentation technique for creating more images, that we do not have a lot of images. That is why we are creating these images. You can see that we have only 101. Okay, then for this we use a TF, that is a TensorFlow. We imported these models from here. Then we have a data augmentation, tf.kg sequential layer experimental pre-processing random flip. Now we are just flipping these images horizontal and vertical. Okay, this is a class. If we add this parameter here, it is just flipping our images horizontal and vertical. Then experimental, it is rotating our images by 0.20 degree. It is rotating. Then for data augmentation, okay, the field is repeated. So then we train our data set and we provide the images to this model for data augmentation. Then it is generated. Now we created our CNN model. Here we have added a first convolutional model. Then we have added a max pooling layer. Okay. Then first our neural network working as. So first it has a input layer, of 32, sorry, 32. Then it is a convolutional. Then we have a pooling layer. Okay, so here you can see that first we have a convolutional 2D model, then we we add a pooling layer, then again we add a convolutional model, then max pooling again. Then again we form a continuous 32, 64, 64, 64. Then we have add a dense layer for identifying, for classifying this image into the given classes. So here first we have a 32, then a 64 into 64 model, then again 64 convolutional layer model, then again 64, 64, and then we have a neural network that identify our model, that is also a 64. So here you can see that we use a activation function, that is a softmax, and here we use a ReLU function. The activation function is used. Uh, okay, so the activation functions are used to analyze these images. We can use there are multiple activation functions like sigmoid, ReLU, softmax we have. Okay, then we created the model layer. Then we are going to build this model using a model.build input shape. We are going to provide input shape. Here we provide input shape, sorry, here we provided a input shape, that is a batch size, image size 255 by 255. Then how many channel and batch size, how many batches we are going to give to this model. So after summarizing this model, you can find a summarization of this model. Here you can see that the convolutional model have a 32 uh, 32 neurons, and then 254 by one, then max pooling actually converting this 254 by 254 image into a 127 by 127. Okay, then next convolutional model we are again giving it 32, then by 125 by 125 images get converted into a 62 by 62 pixels. Then you can see that the pixels are going to reduce 125 to 62, then 60 to 30, then 28 to 14, then 12 to 6 4. It is a neuron, like how many functions, how many, that is I show you simple cell. Okay, features. So it is a detection, so it is detecting one feature. Every neuron is detecting different features and converting this that into a one common feature. Okay, so 32 is given by us in, yeah, number of inputs. Sorry, inputs we are going to give. Here we set the values. Okay, so 64 64, so it is converting, yeah, four values. First 32 is input and it is generating 32 responses. Okay, so first, yeah, first 32 are features and then last 32 are the input generated. Generated. Okay. Hmm. Here channels are three. Okay. Yeah. So here you can see we have used. Okay. So total parameters we have a 1,83,747. Then trainable parameters same. Then we compile this model. Okay. So we are going to calculate this. So after I already trained this model that it is taking a lot of time to. Okay. So here you can see the summary of this model. Again model.compile. Then we are going to see a history, that is model.fit, and here you can see that. Okay, so I think input feature, input type is wrong here, that is why it is showing here, but no problem, we can run this data. Okay, so if I train it again with the different, it will take lot of time. Scores, if you can see here, there is accuracy of a 38%. We can increase that accuracy also. History dot parameters, then again, if you can see, one second. Huh. So here you can see a training and validation accuracy. Okay, then here is a loss, how much our algorithm is uh, not going to identify, that is our loss. So it is a training loss and it is a validation loss. Yeah, it is really worse. Okay, it is around 32. We can pre-process this data and then again train it. By again training, we can improve its accuracy. So, but if we find because of we have very less number of data, okay. So here we are going to give it one data, that is actual level is endophthalmitis and our predicted level is endophthalmitis. We can run this data again, okay, and here you can also see that the image is changed, but the class is same. Actual level and our predicted level is same. Okay, so again let's run it again. Uh, 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 okay, so why it is showing cannot unpack. Hmm. Hmm. Image batch one. Okay, endothalamitis. So here you can see that we change one image, and again let's change image. So the graph is showing endophthalmitis. First images, first 3 4 images are the same, have same class, 12 and 12. So so here is our loss. So actual level is hydrolum, but our model is predicting endothalamitis. Okay, let's check in with the different parameter. So here you can see that endothalamitis. I think endothalamitis is working fine. 15 and 15. We do not have a 15 number of images. 8 and 8. So actually it is a keratitis and it is predicting endothalamitis. So we have very less accuracy with this data. We have to pre-process this data, and again we have to retrain it with the new new pre-processed data. Then we can improve its accuracy, and we can also we can also get a low number of loss here. First of all, we have a data with this, like, 1 second. Mhm. Hmm. So we have data like this. Okay, so we have to create a more number of data. Okay, and then we have to train this model with the generated data. We can we can use data augmentation again and again till we will get a good accuracy. Also we also for hmm. Hmm. We can change these parameters like 32 32, and we can change also this convolutional 2D models. Okay, we can give it first 64 then 32 32. It will give us good output. Okay, so hmm? हाँ accuracy improve होगी वहाँ पे. Okay, so first we have to analyze this data set. Okay, based on this data, okay, using OpenCV and all manually we have to analyze this data set. Then we can create this model using the parameters we would get. Okay, so so 1 second. So here is a zip file you will get on your group. You have to unzip it. There is one data augmentation technique. I will add this data augmentation technique. Okay, it is not completed yet. Then it is a CNN implementation that we have shown, and also there is an image like this. Okay, eye cataract from the below from the given data set. Okay, uh, I will also add one more data set here for the eye disease prediction, that is a cataract, cross-eyes and all. For your practice, you can implement that data set within the same data. Just you have to 1 second. You have to just you have to change just this parameter, and you can use the all this code for the same data set. And you can also pre-process this data using different techniques. Okay, so let's summarize this lecture. So we have seen how convolutional neural network extract feature from the images. Okay, how it detects the edges, how it convert it, and how pooling and convolutional model work. So, and last, we have seen a real world implementation of the model with a with a iDisease data set. Okay, there are other data set also. There is a other data set you can use for your practice, and you can implement this model on this data set. Okay, so thank you so much, everyone. This is the implementation of our model. Okay, so हां, मी मॅमला सेंड करून देणार. मॅम तुम्हाला ग्रुपवरती पाठवून देणार. तो आता पाठवू? ओके, ओके. हो.